Hello and welcome back everyone. My name is Vlad with SolusPLC.com, and today I wanted to revisit a topic that became quite popular in one of our previous tutorials, and that is the Allen Bradley PowerFlex 525 series variable frequency drive. Now, many of you have seen this drive in applications across different industries in the field, and it is a extremely versatile piece of hardware. That being said, what I haven't seen covered in many tutorials are the IO points on this drive that you can see right here, and we're going to dive into the manual to figure out exactly what kind of inputs and outputs can be pulled out and into this drive. Then we're going to talk about the application. So I'm going to be showing you exactly how to wire in a couple of digital inputs that we can test and see on this drive. And then we're going to switch over to the software. So we're going to look on Studio 5000, once again over Ethernet, see exactly where those inputs come in and how you can utilize them in your applications. That being said, before we dive into the technical portion of this tutorial, I do want to mention that we've completely redesigned SolusPLC.com for a much better user experience. The technical tutorials that you're used to reading are still found under the tutorial section, and you can browse and search through them in the search bar, or you can simply scroll down and view all of the tutorials available to you absolutely for free. The next thing that you have access to is the new forum, so we've completely redesigned this as well. And if you want to post a technical question or perhaps a job, a suggestion, or otherwise that's related to automation, controls, or otherwise, you can do so on the forum, and that's usually the best way to reach me. The next thing that we can also access, and the most important one, is that the 7-day free trial. So we've essentially redesigned the way we're selling some of our materials and courses. And if you're interested to give this a try, see if it's something that you'll enjoy, there's a 7-day free trial available, at which point you can decide to unsubscribe or continue with the subscription, which of course supports the channel as well as the community. Alright, so here we are in the PowerFlex 520 series AC drive specifications manual. There's going to be two different manuals, both of which are going to be posted on Solus PLC. That being said, if we go into the overview section, we will be clearly told what are the features of these drives. So you've got the PowerFlex 523 series as well as the PowerFlex 525. For the most part, they are similar, but they will be different. So on the 525 series, we've got 2 analog inputs, we've got 7 digital inputs, 1 analog output that can be configured to either voltage or current, and we've got 2 opto outputs as well as 2 relay outputs. And we are presented with this little diagram, but you'll notice that this manual is not going to be complete in terms of full wiring schemes. So we're going to switch over to the PowerFlex 525 complete AC drive user manual, and here's where we'll find the control IO terminal block that's going to outline each and every input and output. So what we're interested in is, like I said, we're going to do something basic that's going to be utilizing the digital input terminals. So some of them will have to be configured because by default they're going to be for the start push button, but you'll notice that there's going to be a couple of them that will have no other functions. And as we saw in the previous video, these are configured using the parameters of the drive, so you always know where to change them. That being said, what's also interesting are going to be the analog inputs, right? So we've got one here, we've got an analog output, we also got 2 opto outputs, so opto 1 and opto 2. And on the left hand side, I'm not sure why it's on the different side of the drive, you've got the relay 1 and relay 2 normally open and normally closed contact. So we can utilize these as well to our advantage in the field. So the next step for us is going to be to look physically at the drive. So we do have the terminals here that I'm going to be showcasing on the screen as we look at the drive, but we are going to work with 2 digital inputs, and I'm also going to show you the relays. All right, so here's the PowerFlex 525 variable frequency drive. As you can see, I have already removed the front cover that simply slides down when you push on it. And we're going to be looking at the wiring of 2 different things. So here I have a very simple push button with an LED light built in. Let's just quickly move the motor aside and take a look at the connections. So on the push button itself, I've got 2 connections, one set at the top and one set at the bottom. And what you will notice if you look very closely to the metal plate that is traveling down as I press on the button, it makes the bottom set of contacts when the button is pressed in. And in other words, it is a normally open set of contacts. The top one is a normally closed because the plate is, as you can see, closes the circuit when the button is in resting position. So we're going to be wiring that in first, and I've already got two wires set up. It doesn't matter which way they go, as it's just a closed contact. So I'm going to put that down, and let's move back to the PowerFlex. Now, before we land the wires, it's important to mention that you have, based on the prints, a different set of configuration depending if you want this to be a sourcing or syncing inputs. And the way you change that, I don't know how well you can see on the camera, but there's going to be a little jumper that you can essentially pull up with a set of pliers. So here's that little jumper. And then you can either select that your input is going to be sourcing or syncing. And it's a little bit difficult for me to put this back into place since I'm looking over the camera as well as over the microphone. But it goes down as such, and this is going to be the default position, in which case the digital common is currently connected to ground. So what we need to do is send a positive signal or a plus 24 signal to the input in order to change its state. So where can we draw that 24 volts? Well, you notice based on the data sheet that's going to be coming out of pin 11, so we would need to land one of the terminals on pin 11 if I just put this all the way up. So one is going to be going on pin 11, and then we're going to be using a digital input 5. And the reason why we're using digital input 5 is because I want to demonstrate how some of the digital inputs are not present in software and how you can configure them to be seen in Studio 5000. So in other words, we're going to connect between this pin 11 and pin number 5 that you see on the PowerFlex. So let's get that done. And since I already have a cable in pin 11, I'm just going to loosen that a little bit, and we can land a second cable in the same terminal. Of course, if you want to do this in a factory setting, you can definitely bring this out to a separate set of DIN rail based terminals, and then you can land as many wires as you would possibly need. Okay, so that's terminal 11. The next one, as I was saying, is going to be number 5. So there's no other cable inside of there. It should be fairly straightforward. Once again, I'm doing this over a camera as well as a microphone, so it should be a little bit simpler for you to do in the field. So that's terminal number 5, and so that should be all for the button component. Now, on the other side of the buttons, just so I move this over once again, you'll notice that we have a positive and a negative terminal, and that's what's going to power on the light that's inside of this push button. And so once again, we want to make contact for this to enable through a program that we're going to write a little bit later. And therefore, we need to figure out where to land this positive and negative side. And there's going to be several options available. There's going to be the optocoupler outputs, but you also have the relays. And so the relays, in my opinion, are a little bit more interesting in this because our button should, in theory, never really blink, so it should only come on in certain situations, but also because relays are a lot more versatile, so you can certainly add another relay to the optocoupler terminal and then be able to plug them in as such. But in this case, what we're going to do is we're going to utilize the relay, and that's going to be relay 2. Of course, 1 is just as easy to configure. So the connection that we need to make is on the positive side. So if I take the red wire that was plugged into my LED light, I'm going to land that on either side of the relay. So once again, the relay polarity does not matter in this case because we are simply using the contact. Now, the positive side, once the relay is either open or closed, needs to be landed once again on 24 volts DC. And that will require us to use, once again, that terminal number 11 that we just did for the push button. And just to make things easier, instead of shoving another wire into this pin number 11, I'm going to go to pin number 1, which is going to pin 11. So essentially having the same 24 volts DC on that pin at all times. I'm just going to remove or loosen the screw. I'm going to put a jumper in its place, retighten that screw. And as I was saying, this is going to go into R6 because it's going to make the positive signal to the LED. Now we're still left with the negative side of the LED, and the negative side we can pick up on the digital common. So as I had explained, our jumper that we set in the back there is currently connected to ground. And since it is connected to ground, we can simply land the other side of the LED on the terminal 4. Okay, so just to go over really quickly again on the connection side. So on the contact, we've got a positive signal that goes to the button, and then we've got that signal from the button coming into terminal number 05. And on the LED side, we've got a positive signal leaving from pin 1, which is 24 volts DC permanently. And then it goes through the relay number 2 terminals R6 and R5. Those can be interchanged. It goes through our LED, and then the negative side of the LED goes to terminal 4, which is the common that is currently connected to ground because of the selection that we've made on the PCB board that is sitting right here based on the documentation of the drive. So let's power on, let's connect Ethernet, and then we're going to talk about the software side of this drive. All right, so here we are in Studio 5000 on the CompactLogix 1769 L24ER QB1B processor. In the I/O tree, you'll notice that I already have the PowerFlex 525 series set up, and we've looked at this like I've mentioned in a previous tutorial, so feel free to watch one of our previous videos on how to set this up. But if we double click the PowerFlex, a key area that we're going to work with today is going to be in the drive tab. So here we find the parameters, as we discussed once again at the beginning of this video, and also the module definition. So we're going to get into this in just a moment, but what we need to look at before we start making any changes is once again the data sheet. And so here I have the same user manual that we've looked at before, and the two things that we need to configure is the relay, and then we need to configure the input. So we need to be able to read those parameters and write to the relay, of course, to toggle it. And so how do you work with this data sheet? Well, what you can typically do is if you press Control F on your keyboard, you can search for different terms. And in our case, let's start with the relay. So I've already got this typed in, but what I'm doing is I can scroll through the manual and try and figure out how do I need to configure my relay in order to toggle from software. And so you'll notice at the beginning, we looked at the PowerFlex 523 wiring, and here we have the PowerFlex 525, which is exactly what we're looking for. And do note, as we set up our wiring, we are connected on a relay number 2. So as we continue going through this, you'll notice that there will be a section that talks about the relay number 2 terminal wiring. And here's the section in question. So there's going to be two terminals. So we've used the R5 and R6. And by default, this relay or the configuration of the signal is going to be based on motor running. So whenever the motor is running, that relay is going to close. It's going to open because it's normally closed. That being said, there is a parameter which is called out right here on the right side, T081, and we can click it in this PDF to be brought to that specific section. So this parameter is going to be responsible for the function of the second relay on the PowerFlex 525. And what we've got as options, so here we've got the ready fault, we've got at frequency, we've got motor running, which is the default. And by the way, this is what was specified in that previous section. But we need to go down this list and figure out what can we do in order to use this from software. And I've already implemented this, but ultimately we're looking for this option number 13 that reads that output will be directly controlled by the state of T077 or T082. A value of 0 causes the output to turn off. A value of 1 or greater in this parameter causes the output to turn on. So how do we change this parameter? So parameter number T081, it needs to be set to 13. Let's go back to Studio 5000 and close out of this, go into drive parameters. And these are organized by number. So once again, this is going to be parameter 81. And you'll notice that it will have the same description as in the manual. And here we can use a drop down. So we're not necessarily writing a 13, but you'll notice that the number 13 is going to be param control, which is what was specified in the manual. But you'll also know that you can change it by using this internal value, which is currently set to 2. And now that we've set it to parameter control, it has now been set to 13, which is exactly what we need. Now, that's not all we need to do. So what we also need to figure out is we need to go back into the manual. And as I read the sentence, you'll notice that T077 or T082 are going to be the digital values that we can change to set the relay. That being said, so T077, let's go back, 77. So relay 1 and then relay 2, right, is going to be 82. So of course, once again, if we click on the manual, these are just the list for both relays. You need to pay attention that since we're toggling relay 2, we need T082. So T082, relay output 2 level, and let's just put a 1 here. And you'll notice that the relay has immediately turned off, right? So the relay is normally closed. Once this value becomes 1 or above, it's going to open. And of course, the LED is going to turn off. Now, it's really inconvenient to change this parameter from here. How do you get this into our program? So the way you do this is we're going to close out of this. We're going to navigate to General. We're going to click on Change. And here's where you can add additional inputs and outputs for the drive through the data tags. Now, what's a little bit confusing, or I guess difficult to figure out at first, is how to add things into this section. And first of all, you need to be offline. So we're going to cancel out of this. We're going to go offline. Okay, and so once we are offline, what we can do is we can navigate back to the PowerFlex. We double click the PowerFlex configuration, and here we can access the data settings that we need in order to get the data to and from the PowerFlex. I'm going to press on this change. And here, the important distinction is that input data is what comes back from the PowerFlex into the PLC, and output is what goes from the PLC to the PowerFlex. Since we're looking to toggle that parameter that we've talked about, which is going to be T082, we need to put that in the output configuration. If you add it to input data, it's not going to allow you to change it, but rather send the information that's currently on the drive back to the PLC. And just to demonstrate that that is possible, if you go all the way down here, you'll notice that the parameter 82 is definitely in the input data as well, but we need to add it on the output side. So output data, really output 2 level. I'm going to press OK. We are going to change the definition of the drive. That's perfectly fine. Press apply, OK. And now we need to download to the PLC since we have made a major change. So we're going to hit on download. If you do press on go online, it will request the download anyways. So press download. It should switch the PLC back to program mode and then download our application. Once we are back online, you'll notice that the PowerFlex is now faulted out in the IO tree. What we need to do is we need to double click the drive. And the reason for that is because we've downloaded to the PLC this change, but we haven't downloaded to the drive. So if we go back into the drive, you will notice that it is stuck with correlating with online drive. And what has happened essentially is that we're requesting data, or we're trying to send data, but the drive is not able to receive it. So what we need to do is press on this download button, and it's going to finalize everything, and the drive status should hopefully go back to running. as it has done so here. Now we're going to press OK to close this menu, and I'm going to show you how to program that relay in the ladder program. So going back to controller tags, we can identify what is used for the PowerFlex by selecting it in the IO tree and looking at the tags. So PF1, semicolon I, and then O. And since that was defined on the output side, you will find that relay output 2 level on the O section. Now, do notice that this is not going to be present by default in this section. So once you define the drive, it's going to stop at frequency command, and everything you add in that data is going to show up under. So if I write a 1 in this output, you'll notice that the LED is going to immediately turn off. If I put back to 0, it's going to turn on. So effectively, it is changing the relay at that using that register. So this can be used like any other logic in the in your programs. So if we go, for example, into a section for the HMI class, we can create a very basic rung. Just to demonstrate this, I'm going to add another rung. I'm going to put an XIC and an OT instruction. I'm going to paste that bit that I had just copied, and here it's going to be T_flat test. New flat test, boolean, create. We're going to compile the program, press yes. And just to show you, so I'm going to toggle this bit, right click, toggle bit, right click again, toggle bit. And as you can see, obviously the possibilities with this are unlimited. So you can now toggle that relay freely in your software. Now the next thing that we need to figure out is, of course, the push button. So we've landed out on a terminal, and just to demonstrate that, if we go back into controller tags, find the PowerFlex, then the output or the input for that button is not going to be available. You'll notice that I've got digital input 1, 2, 3, 4, but based on the datasheet, we had landed that on digital input 5. So let's go back in the datasheet and see what we need to do next. So I'm just going to use this relay search to go back to the drawing of the PowerFlex 525. So here we've got digital terminal block 05, and as I've mentioned, there's no default input read on that specific block. So what we can do is, so again, so this is 05, we can scroll down, and you'll see that the typical default configuration for digital terminal block 5 is going to be preset frequency. And this is programmed with T065 parameter. So we can click once again on that link and be brought to the parameter in question. So here are all the options for that specific terminal. And so by default, as we had mentioned, this is going to be set to preset frequency. But what we need to put it into is not used, because in not used, this terminal has no function, but can be read over network communications with B013 and B014. And this is controller in status and digital input status. So we're looking for the status of the input. So I can click on this. So first of all, let's configure this, and then we're going to look at digital in status. So let's go back to the PowerFlex. If I scroll down to the PowerFlex, once again, open the configuration, parameters. And so as we said, this was parameter for digital terminal block 5, T065 needs to be set to 0. T065, T065, digital terminal block 5, preset frequency. As I said, we need to set it to 0. I can type it in here, or I can use the drop down. There you go. It is now set to not used. Our next step, as I mentioned, we need to look at the digital input status. So B014. B014 is an integer. And so this integer is going to contain multiple statuses of all the terminal blocks. And since we're only interested in terminal block 5, we just need to read this digit number 1, which is going to be the state of that input. That being said, we do need to go through the process once again. So I'm going to close out of this. I'm going to close out of this. I'm going to go offline. And let's go back to the configuration of the PowerFlex. Change. And so this time we're trying to not set the bits, but we're trying to read the bits. So I'm going to put that in the input data. And as we were discussing, this is going to be digital input status, like so. I'm going to press OK. We are changing the definition, and let's proceed with the apply. Okay, let's proceed with the download. Okay, once again, once we're online, what we need to do is download to the drive. So I'm going to double click the drive. I'm going to go into the drive tab, hit on download, and it should hopefully go back to a running status. Status is running. Let's click OK. And let's see here. So on the input side, we should now see digital terminal block 5, 6, 7, and 8. And that's going to be based on the status. So digital input status that we've added just now. And what you'll notice is once I press the button, I'm just moving away from the table, that the first digit, as mentioned in the manual, now comes on. So of course, if we want to tie this into our software, so let's just go back to the simple ladder logic that we had written on here, and we'll put the status of the button to be tied to the LED of the button. So I'm going to compile that. And what should happen now is once I press the button, the light should turn off. And as you can see, it is working as expected. There are many other options available to use the analog signals, as I had mentioned, because the PowerFlex not only has the digital inputs and outputs, it also has the analog signals. And if you follow the manual in a similar fashion, you'll be able to figure out how to get the data and send the data to analog signals. So the question that comes in after that long discussion is, where should you be using the instrumentation tying in to this PowerFlex 525? And the reality is, I would not recommend you tying in just random devices and sensors of your manufacturing line into just any PowerFlex, but rather take the area that is concentrated on that PowerFlex 525 and utilizing that intelligently to bring in instrumentation that is within that process area. And one example I can give you is an application of a pump. So a pump is a typical variable frequency drive that would be driven by a PowerFlex 525, and then that pump would have several devices. So for example, on the upstream side, you would have a level, which when the level is too low, the PowerFlex 525 needs to stop. So that could be an example of either digital sensor that's going to measure the level, or an analog that measures the entire level and then does a PID loop, which you can do internally on the PowerFlex, but you can also bring in that analog data and then tie it in through your software. And then on the output side, you could have at the exit of the pump a valve that, for example, is driven by pneumatic solenoids from Festo as an example, and that requires 2 digital outputs for the valve, and then you have a signal that comes back from the valve as the feedback of its position, right? So if it's in the open position or in the closed position, and then you have to send signals to activate the pneumatic actuators. So that would be an application where the PowerFlex 525 is taking care of the valve that is upstream, it's taking care of the analog sensor that is the valve that is downstream, and then the analog sensor that is upstream of that specific pump, and it's all related to that PowerFlex. So that would be a case where you wouldn't need additional instrumentation like a point IO block module, and you could all bring that into the PowerFlex. So hopefully that was helpful. If you have any questions, make sure to visit the Solus PLC forums, and I will see everybody next time.